So now that we know the sum and difference formulas, we can use them when verifying other identities. So let's do some practice. In example 7, we are going to try to verify the identity the tangent of pi over 4 plus alpha plus the tangent of pi over 4 minus alpha is equal to 2 times the secant squared of alpha over 1 minus the tangent squared of alpha. All right, so remember how an identity works. We are going to pick one side of the identity to start with, and then we're going to use trigonometric identities and algebraic manipulation to arrive at the other side. Okay, so you should start with the more complicated side, okay, or the side that you feel that you can actually work with. Okay, so when I look at this, I think I can do something with this left side, okay, because I have the tangent of something plus something, and I also have the tangent of something minus something. So I can apply the tangent, the sum and the difference identities for both for tangent. Okay, so that's where I'm going to start here, and then I'm going to try to arrive at the other side. Okay, so always start by writing down the side that you're starting with. Okay, always write that down. Okay, so we're going to start with the left side, tangent of pi over 4 plus alpha. Okay, and then we're going to have a plus. Okay, I'm going to color code this because remember, I'm going to be applying the sum and difference identities to each of these quantities on the left side. Okay, so then we're going to add the tangent of pi over 4 minus alpha. Okay, so what is that going to equal? Okay, so let's start with the quantity in blue. Okay, we need to apply the sum formula for tangent. Okay, so if you go back to page 1, okay, we need to grab that formula. Okay, it's this one. Okay, equation 5. Okay, so I'm going to go back to my problem. Okay, and I'm going to write this identity up here. Okay, so I'm going to be using the fact that the tangent of a plus b is equal to the tangent of a plus the tangent of b divided by 1 minus the tangent of a times the tangent of b. Okay, so when I apply this formula to the blue quantity here, the a value is pi over 4 and the b value is the alpha. Okay, so this is going to turn into the tangent of pi over 4 plus the tangent of alpha divided by 1 minus the tangent of pi over 4 times the tangent of alpha. Okay, all right, so we have applied the sum formula for tangent to the blue quantity. Okay, now we need to add the red quantity. We're going to do the same thing. So for the red quantity, we need to apply the difference formula for tangent. Okay, so going back to page 1, okay, we need to now apply formula number 6, okay, because we have the tangent of something minus something. Okay, so again, up here, I'm going to write my formula. Okay, so now I will be applying tangent of a minus b. That is equal to the tangent of a minus the tangent of b over 1 minus the tangent of a times, 1 plus the tangent of a times the tangent of b. Okay, so if we apply that to this red quantity, the a value is going to be pi over 4 and the b value is going to be the alpha. Remember, the minus sign is taken care of by the formula itself. Okay, so if we apply the formula here, we're going to get the tangent of pi over 4 minus the tangent of alpha over 1 plus the tangent of pi over 4 times the tangent of alpha. Okay, so that was our first step. Okay, applying both the sum formula and the difference formula for tangent. Okay, that leaves us with this mess. Okay, so we have two fractions that we are essentially adding together. Okay, so what we can do now to make this a little easier before we go on is we know what the tangent of pi over 4 is. We can go ahead and plug that in, okay, and then it might make it look a little less scary. Okay, if I go back to the unit circle, okay, if I look at pi over 4, we know the tangent of pi over 4 is 1. So I'm going to plug that in. Okay, so this is going to be, I'm going to go to the blue fraction here. The tangent of pi over 4 is 1. So we're going to get 1 plus the tangent of alpha over 1 minus the tangent of pi over 4 is 1. So this is going to be 1 minus the tangent of alpha. Okay, and then we're going to have our plus sign in the middle. Okay, so the tangent of pi over 4 is 1. So we'll get 1 minus the tangent of alpha over, in the bottom, we'll have 1 plus the tangent of pi over 4 is 1. So this will just become 1 plus the tangent of alpha. Okay, so it looks slightly less scary. Okay, remember the end goal. Okay, we are trying to arrive at this 2 times the secant squared of alpha over 1 minus the tangent squared of alpha. Okay, all right, so we just continue on. Okay, now we've got to do some algebra. Okay, we are adding two fractions. Let's try to combine them into one because the end goal is a single fraction. Okay, so to add fractions, we need a common denominator. So if you don't know what your common denominator is, just multiply the denominators together. Okay, so our denominator here is going to be 1 minus the tangent of alpha times 1 plus the tangent of alpha. Okay, so now we need to figure out what goes in the numerator here. Okay, all right, so when I'm doing this, okay, so let me give myself some room here. If I look at this first fraction, okay, what is missing from the denominator? Well, we already have the 1 minus the tangent of alpha, so we want the denominator to be 1 plus the tangent of alpha times 1 minus the tangent of alpha. So we have to multiply by this other factor. If we do it to the bottom, we have to do it to the top as well. Okay, so what's going to go in the numerator for this piece is going to be 1 plus the tangent of alpha times 1 plus the tangent of alpha. Okay, so that handles that first fraction. Okay, and I'm going to get rid of this. Okay, and now we have to do the same thing to the other fraction. Okay, I'm going to put my plus sign in the middle, like this plus sign is going to go right here. Okay, and now I need to work on the second fraction. Okay, compare the denominators. In this second fraction, we already have the 1 plus tangent of alpha in the denominator. So to make it the denominator we want, we have to multiply the bottom by 1 minus the tangent of alpha. Okay, if we do that to the bottom, we have to do it to the top. Okay, so the numerator is going to end up being 1 minus the tangent of alpha times 1 minus the tangent of alpha. Okay, so that gets us everything combined into one fraction here. Okay, so now we just continue on doing algebra. Okay, follow your gut. What do you think you can do next? Well, let me go ahead and distribute in the numerator. Okay, so if we FOIL right here, multiply this out, 1 times 1 is 1, and then 1 times tangent of alpha is going to be plus tangent of alpha, and then we do the inner terms, tangent alpha times 1 is going to be another plus tangent of alpha, and then multiply the last terms together, tangent of alpha times tangent of alpha, that's going to be tangent squared alpha. Okay, and then we have our plus sign. Okay, that's our plus sign in the middle. We've got to FOIL on the right side as well. Okay, so now we're going to get 1 times 1 is 1. And then we're going to do the outer terms. 1 times negative tangent alpha is going to be minus tangent alpha. the inner terms, negative tangent alpha times 1 is going to be negative tangent alpha. And then the last terms, negative tangent alpha times negative tangent alpha is going to be plus tangent squared alpha. Okay, so that's what we get when we multiply everything out in the numerator. Okay, I'm going to hold off multiplying out the denominator because sometimes you can get things to cancel and you can't see it if it's multiplied out. Okay, so I'm just going to leave this alone for right now. We'll see what happens. Okay. All right, so we need to clean up the numerator. Okay, so let's see what we have. Okay, when I look at this, I see a positive tangent of alpha canceling with a negative one. Okay, so those will cancel. I see another positive tangent alpha canceling with a negative one. Okay, and then I see my ones. I have 1 plus 1. I can combine that into 2. Okay, and then I have a tangent squared alpha plus another tangent squared alpha. Okay, so these guys I can combine. So this is going to be plus 2 times the tangent squared of alpha. Okay, so that's what happens in the numerator. And I'm going to go back and look at my goal. Okay, my goal, the denominator is 1 minus tangent squared of alpha. Okay, I think I can get that if I multiply out the bottom. So I'm going to go ahead now and multiply out the bottom. Okay, if we multiply out the bottom, 1 times 1 is going to give us 1. And then if we do the outer terms, 1 times tangent of alpha is going to give us plus tangent alpha. And then the inner terms, negative tangent alpha times 1 is going to give us minus tangent alpha. And then the last terms, negative tangent alpha times tangent of alpha will give us minus tangent squared alpha. Okay. All right. In the denominator, positive tangent alpha cancels with the negative one. Okay. All right. So we have our denominator, which is great. Okay. Once those tangents cancel, we're left with 1 minus tangent squared alpha. Okay, and if you go back to the goal, the right-hand side of the identity, we have the denominator, 1 minus the tangent of squared of alpha. Okay, we just need to work on the numerator. The numerator needs to be 2 times the secant squared of alpha. Okay, so let's see what we can do. Okay. In the numerator, we left off with 2 plus 2 times the tangent squared of alpha. Both of those terms have a 2, so we can factor it out. So if we factor out the 2, that's going to leave us with 1 plus the tangent squared of alpha. Okay, and then at this point, what I'm highlighting here in yellow, this is a Pythagorean identity. Okay, if you remember, I'm writing this out to the side. 1 plus tangent squared of alpha is equal to secant squared of alpha. Okay, so if we apply the Pythagorean identity here, okay, this is going to turn into 2 times the yellow stuff is secant squared of alpha, and the bottom is still 1 minus the tangent squared of alpha, and this is precisely the right side of the identity we were trying to prove. Okay, so we are done.